So first of all, for these physics lessons, you can see they give us the exam format for SPM. Of course, this is the new syllabus from the year 2021. So it's a little bit different in terms of the chapters. So you see the exams format. First, we have the paper 1. Paper 1 multiple choice, 40 questions, 40 marks, 1 hour 15 minutes. Paper 2 is subjective questions, structures and essay questions. And paper 3, practical questions. So practical questions is like experiments, but you have to write it down. Okay, write it down, and 45 minutes. So the marks given, 40 marks, 100 marks, and 15 marks. Okay, so this is the first chapter. So first chapter, measurement. So we start with this, 1.1. So 1.1, we have physical quantities. Okay, so what is physical quantities? For example, mass, volume, length, and so on. All these are physical quantities, something that you can measure. So that's why the definition, a physical quantity is a quantity that can be measured. Okay, so you can measure mass, you can measure volume and length. Okay. Physical quantity consists of base quantities and derived quantities. Okay, so for base quantities, so we have to know there are 5 where we can remember it by using T, melt, temperature, melt. Okay, T, melt. So T, temperature, M, mass, E, electric current, L, length, T, temperature, the last one, temperature, melt. Okay, the last one, length, mass, time. The last one is time. Okay, so these are the 5 base quantities. Of course, beside these 5, there sometimes you may see 2 more. Which is luminous, intensity, and amount of substance. That means mole. And okay, so these 2 are quite rare in SPM, but the first 5, temperature, mass, length, time, and electric current, these 5 are more common. Okay, so we have 5 base quantity plus 2 more, which is less common. Okay, now let's move on. Derived quantities other than the 7 base quantities here. Okay, so there are derived quantities. For example, volume. Okay, so volume derived from length. So length multiply with length multiply with length, then you get volume. So derived quantities. So you get it from base quantities. Okay, another example is like length divided by time, you get speed. So speed is derived quantities. Number 3, a physical quantity must be stated in magnitude with its unit. Okay, so that means, for example, length 10 cm. 10 is the magnitude, cm is the unit. So example, length 200 meter, 200 is the magnitude, m is the unit. Length is the physical quantity, so you must put unit. Number 4, Physical quantities may be stated in metric or imperial units. Okay, so that means you have to put in units. Okay, in units. So what kind of units? Let's say examples. Examples of metric units are meter, liter, and gram, while examples of imperial units are inch, foot, gallon, and yard. So you can see that metric is the standard unit, the more common one. Imperial units is like maybe it is used in a particular aspect of life. Let's say, for example, food is used in talking about the length of house, the width of house, or the length of the house. Okay, so in a particular aspect only we use foot. Okay, so but for scientific study we use metric units a lot, so meter, liter, and grams. Okay, now let's move on. Quantities, base quantities and derived quantities. So first we have base quantities. It's a physical quantity which cannot be derived from another physical quantity. Okay, so that means cannot derive. It is the base. So there are 7 base quantities: length, mass, time, thermodynamic temperature, electric current. So this is the T melt that I mean. Luminous intensity, amount of substance. Let's see the SI unit. So SI unit and its symbol. So you can see here, for length we use meter. You must memorize, you must memorize the SI unit. So length, meter. So that means when you apply formula, right, you have to change your kilometer to meter, you have to change your centimeter to meter before you use formula. Okay? So mass, kilogram, not gram. Some people misunderstand, use gram. Chemistry, gram. Physics, kilograms. Time, second. Temperature, Kelvin. Okay, Kelvin. So maybe you feel like, oh, Kelvin, I used to use degree Celsius. So if you have degree Celsius, you have to add 273 to change it to Kelvin. Okay, then we have electric current, ampere, intensity, candela. So intensity means the brightness of lights, for example. Okay, candela. The amount of substance is more to chemistry. This is mole. Okay, so these are the 7 base quantities. Okay, now we look at derived quantities. Physical quantities derive from 2 or more base quantities through multiplication or division or both. So you can see area is length power 2. So length multiply with length. You can see they use a base quantity, length, multiply, and get the derived quantity area, symbol meter square. Volume, length multiply with length. Density, mass over volume, so which means mass over length times length. So you see that they put everything under base quantities, and because of that the unit m is kg, the length power 3 is meter to the power of -3.
Okay. Need to memorize it?
No need actually. For now, you just take it like that. In future, when it comes to the suitable time, then the formula will come out again, and then at that point you memorize. Now you don't memorize anything first. You just need to memorize the 7 base quantities, and then the derived quantities no need to memorize first. Yeah, so let's move on. Okay, so velocity, length over time, acceleration, velocity over time, and then you change velocity to length over time. So that's why you have length over time and time again. So that's why meter per second per second. Force is mass times acceleration. Acceleration that replaces with L over T square. So that's why it is related to the previous one. So we have mass kg and then ms negative 2. Momentum P equal to mv. Pressure P equal to force over area. Work force times length. Charge current multiplied with time. Weight mass multiplied with g, the gravitational acceleration. Power work done over time. So like what I said, all these formula we have quite many here. Just take it like that only, look at it, and then we just continue our chapter. Okay, so if you meet this again and at that time you remember it. So now it's like you need to know how they change everything to base quantities, and that will be good enough already. Okay? How they change it to base quantity. Resistance, voltage over current, and then they put the base quantity one by one. Okay, so we have the working there. Okay, so I just leave it like this first. Let's move on.
Also, exam won't ask.
They will ask actually. They will ask you to put these in base quantities and then derive the units. Yeah, they will ask. Okay, so if you memorize it now by heart, right, it's a bit hard, it's a bit hard. Okay, so at the end, after you learn physics for months, you come back and look at this, and then you will realize, oh, this is already in your mind. So at this point, just look at it and then keep moving. So that is my suggestion. You memorize it now, you feel like very suffering. Okay, so just leave it like this first. Okay, now if we do questions and you realize you haven't remembered the formula, so what to do? Just refer back to this table again. But just before SPM, for sure all this is in your brain if you study everything properly. Okay, so we have learned base quantities and derived quantities until now. Okay, so we just continue. Scalar quantities and vector quantities. So this is the second way to make the physical quantities into two groups. Just now the first way is base quantity and derived quantity. That is the first way. Now the second way here, we make the physical quantity into scalar quantities and vector quantities. Okay, so let's see. Scalar quantities are physical quantities that have magnitude only, no direction. That means no direction. Magnitude only. Magnitude means has value only. So example, students run a distance of 50 meters, magnitude 50 meters, direction, no directions. Okay, so distance is a scalar quantity. So scalar quantities. Vector quantities are physical quantities that have both magnitude and direction. So it has both. So for example, students run a distance of 50 meters to the west. So in this case, when they state the directions together with the magnitude, we call this displacement. Displacement is very similar to distance. It's just that distance, we have magnitudes and we don't care about the direction. We don't mention the direction. But displacement, we mentioned about the magnitude. The magnitude is the distance. We also mentioned about the direction. So that's why displacement is a vector quantities. Okay, so let's move on. So you can see the magnitude is 50 meters. The direction is west. Okay, so look at this table. You can see they put the scalar quantities in the first column. We have distance, speed, work, temperature, energy, mass, power, area. So need to memorize or not? Yes. Okay, so you need to memorize. Okay, memorize. So normally I suggest you to memorize maybe scalar quantities, and then after that anything that is not under scalar quantity will be vectors, vector quantities. So for example, distance, the displacement is the vector quantity, okay, which is very close to distance. Speed, how fast the thing move without direction, but velocity is how fast the thing move with directions. So related. Okay, force, acceleration, momentum, weight. So these are vector quantities. Okay, so which means it has directions. So for example, for displacement, right? Let's say for displacement, it is kind of common where they put like this. If s equal to, let's say, okay, if an object moves to the right by 3 meter, so displacement equal to positive 3 meter. So if an object moves to the left by 2.5 meter, displacement equal to negative 2.5 meter. So we used to put plus minus to represent the directions. Okay, so that's the thing. Okay.
Up and down is
Yes, even up and down. Up positive and down negative. Okay, so let me ask something like this. Okay, so how they ask 1.1 in exam questions. So let's say, for example, they give you power P, then they give you formula work done over time, then they ask you to determine the SI unit. They ask you to determine the SI unit. Okay, so I demo one time and you see how we work it out. So power equal to work done over time. They give us a formula. Okay, they give us a formula. So we have to know that work done is force multiplied with displacement. Force multiplied with displacement. Okay, so we have to know that force is mass times acceleration. So we have to know that acceleration is velocity divided by time. We have to know that velocity is displacement over time. Okay, now it comes to the base quantities already. Okay, so where this one is meter, this one is second. So we get to know that this is meter per second. So we get to know that this is meter per second, this is second. So meter per second divided by second, we get meter per second per second. Okay, now we know that this is kg, this is meter per second per second. So end up with kg, meter per second per second. So you see we do backwards. then you know that force is kg meter per second, displacement is meter, okay, then we multiply, then we get kg meter square per second, and then we know that, okay, we do backward again, then we know that W is kg meter square s negative 2, this is second, okay, then we know that this is kg meter square s negative 3. So at the end we get the answer. So this is the SI unit. So that means everything in the base quantity, in the units of the base quantity. So we have the mass, the length, okay, you can see kg represent the mass, m represent, meter represent the length, s represent the time. So it is in the units of base quantity. So that is how they ask.
Need to write the whole thing.
No need one. It's a multiple choice questions. So I just show you the process of thinking. So we think like this. But in exam, how you do it, they don't mind one because it's multiple choice, right? Or objective questions. So as long as you choose the ABCD correctly, then they give you marks already. Okay, so
One for math, we only ask objective.
Yeah, objective. So chapter 1, objective. Okay. Now let's see 1.2 then. 1.2 scientific investigation. So that means experiment. Number 1, interpreting data in a graphical form is an important step in scientific process skill. So that means they give you a graph, then you need to understand the information from the graph. Okay, so physics is more to graph, just for your information. Okay, now the shapes of the graph can determine the relationship between two physical quantities. Okay, so let's see the first type of graph. You have a straight line coming out from origin and go up in this way. So for this graph 1, of course, we say a straight line that passes through the origin. Okay, so passes through the origin. This is the origin. So come up from here. Okay, now let's look at what they do here. They are trying to do y2 minus y1 to find out the vertical distance, then x2 minus x1 to find out the horizontal distance. Okay, so of course after that they are going to take this divided by this, where we need to know that gradient equal to y2 minus y1 x2 minus x1. So you can find out the gradient from this graph. Okay, so and then after that you can find out the equation. Okay, the equation is y equal to mx. Y equal to mx. It's a straight line from origin. Okay, y equal to mx. Okay, let's see the next page. Okay, so you can see the interpretation of graph. Y is directly proportional to x, and this is very important. They like to ask this. State the relationship between x and y. So the answer is, if you see the graph come up from origin, you just say y is directly proportional to x. Okay, so another example. Okay, let's say if you have, sometimes your graph is labeled in different way. Okay, so let's say you have temperature and volume, a straight line from origin. Then the question asks, state the relationship between the volume and the temperature. So your answer is V is directly proportional to T. Okay. So it means when T increases, then V increases. It means something like that. Okay. Now we also have the gradients formula. So this is the gradients formula, and then the equations. Once you get the gradient, you put it here, y equal to mx. Okay, so of course you have to know that the straight lines equation is y equal to mx plus c, yeah? But for this case the c is 0. Okay, now we look at graph 2. Type of graph: a straight line with a positive gradient that does not pass through the origin. So that means there is a y-intercept over here. So it's a straight line with y-intercept. So how we set out the relationship: y increases linearly with x. So remember this way. Just now directly proportional, now increases linearly. The difference is this one, it has an y-intercept here, but just now the y-intercept is 0. Okay, come up from origin, in other words. Okay, the gradient formula is the same, y2 minus y1 over x2 minus x1. And then the y-intercept is c, which is this point. The straight line cut the y-axis. The linear equation is y equal to mx plus c. Okay, so that is the second graph. Okay, now let's look at the graph 3. So the type of graph: a straight line with a negative gradient. So that means it goes down. That does not pass through the origin. So there is a y-intercept here. Okay, now how we set out the relationship, you can see on this side, y decreases linearly with x. Okay, so decreases linearly. Just now increases linearly. So when there is y-intercept, increases linearly or decreases linearly. Gradients of graph, same formula. Y-intercept c, equation, same formula. Y equal to mx plus c. Okay, now the fourth, graph 4, the type of graph. So you can see it is a curve now. So a curve with positive gradient that passes through the origin. So the curve can be this way or this way. Okay, so we set out the relationship in this way: y increases with x. We don't say it linearly because it's not straight line. We just say increases. Okay, so increase in this way or that way. Formula, no need to know. Okay, so it's a quadratic formula basically, but no need to know. Okay, in physics they don't focus that much on the formula when it is a curve. Okay, so of course in maths we know, this is quadratic, x square. This one, what kind of graph? It is not even in maths syllabus. It is y square graph. Y square graph, so no need to know. Okay, now we look at graph 5. The type of graph: a curve with a negative gradient that does not pass through the origin. Okay, so let's see the graph. You can see it here. This side, y decreases with x. Okay, so you can see the curve going down this way or this way. Okay, decreases. Okay, then we have graph 6. Again, no need to know about the equation of the graph. Okay, no need to know. Okay, graph 6, type of graph: a curve with a negative gradient that does not cut both axes. That means it is like this. Okay, so you can see that parallel with the the y-axis, and parallel with the x-axis. So it doesn't cut the axis. Okay, so a straight line y against 1 over x with a positive gradient that passes through the origin. So what are they trying to say here is this graph can change into a straight line if you change the x-axis to 1 over x, and then it becomes a straight line from origin. Okay, so if you don't change it, you just keep it as y and x, then it will be a graph in this way. If you change the x-axis to 1 over x, then it becomes a straight line from origin. So because of that, the relationship, you must be careful. You have to say y is inversely proportional to x. Y is inversely proportional to x. Okay, so for both situations, for this graph, or the graph here, you have to say it as y is inversely proportional to x. So that is the popular question that will ask you the relationship between the graph. Of course, I have to tell you also there is another accepted way to set out the relationship for this situation. You can also say, if it's straight line from origin, right? Just now in graph 1, we said y is directly proportional to x. Now you can say y is directly proportional to 1 over x. So this is accepted also. If you don't want to, sorry?
Two answers also.
Yeah, two answers are accepted. If you don't want this, you just write back the just now. Y is inversely proportional. Inversely proportional to x. So both will be accepted. Okay, so we prefer to change the graph to straight line so that we can do predictions. Okay, so for example, if it's a curve like this, you change it to straight line, then you can make the line longer to predict if the x value is others, then what will be the y values, you can predict. So straight line is preferred. Okay, now let's see the next part. Analyzing graph to summarize an investigation. So in general, there are 5 important aspects in analyzing graph. The relationship between two variables. Okay, so I hope you still remember we have directly proportional, increases linearly, decreases linearly, increases, decreases, and inversely proportional. Okay, so relationship. Okay, so method: interpret the shape of graph obtained. You look at the shape, so straight line from origin or straight line from a particular y-intercept, okay, or curve without touching both axes, so you have to look at those shapes. Number 2, the gradient of the graph. So you count the gradient by using the gradient formula. Okay, so why gradient is important? For example, let's say if you have distance, time, then you count the gradient for this. The gradient represents the speed. It represents something. Okay, so how you know it represents speed? Okay, that is an easier way to know. You just take whatever on the y-axis, divide by whatever on the x-axis. So you have distance on the y-axis, divide by time on the x-axis, and then you know, okay, distance over time, it is speed. So gradient is speed. Just take the quantity on the y-axis, divide by the quantity on the x-axis, and then you will get what is represented by the gradient. Okay. Another example, let's say if you have graph with displacement versus time, okay, then we know that the gradient is velocity. So why velocity? Because like what I said, you take the the quantity on the y-axis, displacement, divide by time. Displacement over time is velocity. So the gradient means something. Okay, now the next one, the area under the graph. Okay, so area under the graph means something also. Okay, let's see the next page first. So on this page, they say calculate the area under the graph using the relevance formula for the area. Okay, so you can see here, if let's say you want to find this area, so you can count the area of triangle, then add up with the area of rectangle, and then you get area under the graph. Okay, area under the graph represents some things for some graph. For example, if you have velocity versus time, okay, so which is like this, okay, then the area represent displacement. How we know the area represent displacement? There is a way to help us. You try to take the y-axis, multiply with the x-axis. Velocity multiplied with time is displacement. Then the area represent displacement. So you can see two skews over here. Gradient, you take y divided by the x-axis. Area, you take the quantity on the y-axis multiply with the quantity on the x-axis. If they represent something, then the area has meaning. Okay, so sometimes the area has no meaning. When you multiply the quantity here, I mean the quantity on the y-axis, you multiply the quantity on the y-axis with the quantity on the x-axis. If you realize it doesn't have any meaning after multiplying, then that means the area doesn't represent any quantities. Okay, so we have something like this. Okay, then let's move on. Now let's look at number 4, the interpolations to determine the value of a physical quantity. So you see the method. If the values of x is given, determine the values of y using interpolation and vice versa. So that means you have a graph like this. So this is the graph given. So you can use this graph to find out the corresponding value of y, for example. Let's say if x is 2, you bring x equal to 2 to the graph, then you bring it to the side, then you look for the values of y. So this is what we call interpolation. Okay, again, you can let x equal to 1, then you bring it to the graph, then you look for the values of y. So that is what we call interpolation. So we use the values of x given to determine the value of y based on the graph. Okay, vice versa, that means in the opposite way, that means you can use the values of y, 20 for example, bring it to the graph, bring down, then you look for the x, 1 point something. So this is interpolation. Then what is extrapolation? So let's see. The extrapolations is to make a prediction. So the method is, you can see here, A, extrapolate the graph. So what is extrapolate the graph? You can see the picture over here first. So this is the graph that we have. Okay, from here to here. So sometimes we will realize that the graph is not long enough, so we extrapolate the graph, make the line longer. Okay, so you extrapolate the graph, and after that, let's see the next point. Determine the values of x or y constant. So you extrapolate the graph, and after that you do predictions of value. Let's say x is -1, you bring to the extrapolated line and you find out the corresponding values of y. So this is extrapolation, where it involves 2 steps. Make the line longer and then predict the corresponding value of y. Compared to interpolation, we don't make the line longer, we don't make the graph longer. So that is the difference. Okay, we have experiments. Okay, before we look at experiments, let's see some examples of graph questions. So for example, let's say they may ask something like this. They give you a graph. Then they give you values. Then they ask you to find out the equation that represent this graph, the equation. So what we need to do is we find the gradient. y2 minus y1, x2 minus x1. We can change this to coordinate 0, 10, minus 5, 0. So this is x1, y1, x2, y2. Okay, then we count the gradient. y2 minus y1, 10 minus 0. x2 minus x1, 0 minus -5. So we divide, we get 2. So we get the gradient. You know, y equal to mx plus c is the formula. So now the c is the y-intercept. The y-intercept is 10. The graph cut the y-axis at 10. So y-intercept is 10. So our equation is y equal to 2x plus 10. Okay, so they will ask something like this. They give us a graph, we find the relationship. Okay, so of course they may also ask something else, like they give you a graph, then they ask for the relationship in words, like directly proportional, inversely proportional. Okay, now experiment 1.1. Okay, this is more to paper 3. Paper 3, written experiments. Okay, so let's see the topics. Investigate the relationship between the length of a simple pendulum L and the period of oscillation of the simple pendulum T. Okay, so that means it is something like this. You have a pendulum with the bob at the bottom. Pendulum is basically a string with an object down here. Then you make this swing. Okay, so when it swing, then you count the period. So what is meant by period? Period is the time span. For example, when the bob reach here until here, then come back here, the time span from the starting point, go back to the same point, the time span will be period. So we want to see the relationship between the length of this pendulum or the length of this string with the period. So of course you should be able to predict if it's very long, right? Maybe through observation you see that when it's very long, then it will take a longer time for one period. Yeah, so that is based on maybe past experiments or maybe from observations before. So you should know that. Okay, so sorry.
I do before.
Oh, you do before, and then should be okay, so if the length is longer, then the period is longer. Okay, so from previous experience, okay, so you can do hypothesis. That means you predict what will happen. The longer the length of the simple pendulum, the longer its periods of oscillation. So that is hypothesis. Hypothesis means you predict the result. Okay. So we always write in this format. Inference means you set up the relationship between the variables. Okay, so the period of oscillation of a simple pendulum depends on its length. Okay, so how to say inference? We always say something like this. We say the responding variable depends on manipulated variable. Okay, so the format of inference. Responding variable depends on manipulating variable. What is the format of writing hypothesis? So from here you should be able to see something like this. The higher or lower of the higher the lower the manipulated variable, the higher or lower the responding variable. So this is the format of writing hypothesis. Okay, the arrow represent higher, lower, or longer, shorter. So it depends on the situation. Okay, now the aim to investigate the relationship between the length of a simple pendulum and the period of oscillation of the simple pendulum T. So how to write aim? So the general format, this one you have to memorize. To investigate, if you don't want investigate, you just write to study. To investigate the relationship between MV and RV. So this is the format to write the aim. Okay, now we have the variable, manipulated variable. So the variable that we set ourselves, length of pendulum. So we set the length. Responding variable is the variable that change after you change the manipulated variable. So when you change the length, then the period change. Okay, so this is the responding variable, period of oscillation. Constant variable, the variable that doesn't change throughout the whole experiment. So mass of pendulum bob, constant. So apparatus, retort, stand, protractor, pendulum, bob, stopwatch, meter rule, and G-clamp. Okay, so material, 100 cm thread and 2 small pieces of plywood. Okay, so let's move on. Okay, so So you can see why they use plywood. They put in between of the G clamp, the plywood. So the plywood is to hold the thread, and then you have the pendulum here, then you swing. Okay, of course you have to set your angle, then you swing, you count the period. Okay, now we have the procedure over here. Procedure number 1, all the apparatus are set up as shown in diagram 1.11. The pendulum is adjusted so that its length is 20.0 cm. Okay, so maybe you are wondering, can I write 20 cm or not? I don't want to write 20.0 cm. I write 20 cm. Is that okay or not? It depends on the apparatus that you use. For example, you are using ruler. Okay, you are using ruler. Your ruler can read until like 0.1 cm, 0.2 cm, and then you have to write 1 decimal. Okay, so for example, in what situation you can use 20 cm without 20.0? Measuring tape. Okay, so if you are using measuring tape, the measuring tape depends on what kind of measuring tape. Certain measuring tape, right, they don't show decimal one, they just show 1 cm, 2 cm. And then in that case, you can avoid writing 20.0 cm. Okay, so it depends on apparatus. Certain apparatus will show up to 2 decimal, then you have to write 2 decimal. Okay, like linear calipers. Okay, so we will learn that in details later. So there are many skills that we need to build up here and there. So the pendulum bob is displaced at an angle of less than 10 degree. So you pull it sideways 10 degree from the vertical and release. The time taken for 20 complete oscillation is measured using a stopwatch, and the time is recorded as T1. 20 oscillation. That means you have to wait for you start from here, right? So the bob come here, then come back to A again. That is 1 period. So go here, come back again, 2 period, then 3, and so on. Until 20 period, you stop the stopwatch, then you check the time. Okay, so you must stay alert all the time. Cannot do like, okay, think of other things and I forgot to count 20 oscillations. Step 4 is repeated and the time is recorded as T2. Okay, so that means you have to do it twice. The average time, T1 plus T2 over 2, is calculated. The period is calculated using T equal to T average over 20. The value of T square is calculated and recorded. Step 2 to 8 are repeated with length of pendulum 30, 40, 50, 60, and 70 cm. All data are recorded in table 1.4. Okay, so you can see the table here. T1, T2, then take average, then you divide by 20 to get the period, then you square it. So if you are wondering why they square it, it is actually because they want to get straight line. They know that T square versus L is a straight line graph. So that's why they square it. Okay, now you see here, analysis of data. So analysis of data is about graph and calculation. T square versus L is a straight line from origin. Okay, so you have to use graph paper to get the graph. Okay, then they count the gradient. So they get this value. And why this value is second square cm negative 1? It's based on, like what I said, you take this divide by this for gradient. So the unit, just do accordingly. Second square divide by cm, then you get this unit. Okay, then the period of oscillation of pendulum T equal to 2 pi square roots of L over G. No need to memorize this formula. Okay, we have a formula which look like this: T square equal to 4 pi square L over G. No need to memorize that. This formula will tell you why it is a straight line from origin. Okay, basically because of something like this. This one. T square equal to 4 pi square over G times L. This is Y, this is M, this is X. So that's why Y is T square. The y-axis is T square. The gradient is 4 pi square over G. The x-axis is L, as you can see here. Then you count the gradient for what? You count the gradient so that you can equal it to 4 pi square over G. Then you can count the G. So gradient equal to 4 pi square over G. Then you rearrange the equations. Bring the G to the left. Bring the M down. And then you divide. 4 pi square divided by M. The gradient. The M here is the gradient, and this value. You put it down here. Then you divide. You will get the gravitational acceleration. 921.10. Example only. Okay, so this part is just example. Okay, so no need to do like from where I know this formula. I never come across this formula, so I cannot understand the experiment because I don't know this formula. It's okay. This formula, just look at it and try to understand how they get the G. They use straight line, y equal to mx. The m is this one, then they count the m, the gradient, then equal to this, then rearrange them and count the G. Conclusions: graph T square against L is a straight line passing through the origin O, showing that T square is directly proportional to L. Okay, so this is the whole experiment. So paper 3 will be something like this. Okay, so we have done the theory part for this chapter. Okay, so we have to practice. Okay, I show you 1 or 2 questions, then you see how we answer it. Then after that, it will be your turn to answer. Okay, so just 1 or 2 only. Let's say, for example, which quantity is base quantities? Okay, so this first question. So they expect you to know. They expect you to know. You have memorized the 7 base quantities. Okay, so volume. Volume is length times length times length. So because of that, it is derived quantity. Energy is derived quantity. Okay, derived quantity. So for example, kinetic energy is 1/2 times mass times velocity power 2. So it's derived quantity. Electric power, for example, electric power is energy over time. So it's derived quantity. So luminous intensity is base quantity. Okay, so let's see one more example again. Which of the following quantity is a derived quantity? Density, yes, because mass over volume. So derived quantity. Thermodynamic temperature, so this is base quantity. This one is in Kelvin. Electric charge, no. Electric current, yes. Electric current is base quantity. So electric charge is derived quantity. So charge equal to IT. How you know? Just look at the table. Okay, just look at the table. Don't memorize first. Okay, so it's very hard to memorize at this point. Just look at the previous page table, then look at that and find out. Okay, current, base quantity. Base quantity. Okay, so derived quantity 1 and 3. So the answer is B. This one we discussed before, question 3. Let's see question 4. Which of the following is a vector quantity? So you know mass is a scalar. Mass is a scalar, no direction. Age is about time, so time no direction. Okay, so donkey. Earth gravitational pull on our body. Yes. Okay. Act downwards. So that is vector quantity. Okay. Now let's see how they ask graph questions. Okay. The diagram below shows a graph of the relationship between resistance and cross-sectional area. Okay, so you can see a straight line from origin. R is directly proportional to 1 over A. So, correct? Yeah. So you know just now I said there are two ways. You can say R is inversely proportional to A, or R is directly proportional to 1 over A. So this one is correct. This B is wrong because R is inversely proportional to A. C increases linearly, then must have y-intercept. Decreases linearly, must have y-intercept. So A is correct. Okay, so you roughly know already how they ask, and consider settled for this chapter 1.